What is truth? That was the rhetorical question by Pontius Pilate when he was facing truth itself. And yet that's going to be the basic challenge before us all. How do we really know what's true? We take that so for granted, and yet there are tools and there's a science of understanding truth. How do we know the Bible is true? That's perhaps the most crucial question among us. We're going to approach this in a rather unorthodox manner. We're going to start by talking about the boundaries of our reality. How do you examine them? How do you qualify sources of information? And how do you test hypotheses to find out whether they're true or not? There are standard tools that we need to be aware of to do these things. Well, our challenges before us, of course, first of all, deal with our skeptical environment that we find ourselves in. We have attacks on every side for the very existence of truth. We live in a society that espouses value relativism. You have your truth, I have mine, which is utter nonsense in terms of denying the existence of absolute truth. And this, of course, is accompanied with attacks on the Bible itself, the fountain of truth for mankind, the very basis of our heritage. And, of course, attacks on the Lord himself. Now, this is all in a background of cosmic warfare. We understand from the Scripture that we are faced with spiritual adversaries that deal with the principal weapons of deceit and doubt. That was Satan's first move in the Garden of Eden, to ask the question, yea, hath God said? Raising doubts that God really said what he said. And that strategy echoes throughout the centuries and is very, very extant in our civilization today. So how do we know the Bible is true? You know, there are testimonies from the past. There are scholastic evidences, manuscript evidence. We could go through all the different translations and authentications of the manuscripts. We can also deal with the testimony of contemporary eyewitnesses at the time. And this is the traditional approach to dealing with defending the Bible, its veracity, its truthfulness, and so forth. We're not going to spend much time on that because that tends to be scholastic, tends to be academic, tends to be a little distant from where you and I really live. And so we're going to focus more intensely on testimonies from the present. We're going to explore the very boundaries of what we think of as reality itself before we go any further. We're going to talk a little bit about the lessons of modern science. It's really quite astonishing to realize how the discoveries of modern science of just the last century or so have totally altered our understanding of the reality that we live in. We're going to talk, strangely enough, about messages from outside the boundaries of our reality. Messages that actually have their origin that are extraterrestrial, outside the space-time you and I inhabit. And we'll talk also about some hidden discoveries in the biblical text itself that may surprise you. It's this last area that we're going to focus on most intensely. But we're doing all this in the advent of a very popular book, The Da Vinci Code by Dan Brown. Very readable novel, very cleverly crafted. And yet, although it masquerades as a novel, it confronts the reader with a fact sheet up front with 3 paragraphs claiming that these things in the paragraphs are true and accurate when they're not. They're deliberate deceptions and not accidental misunderstandings, a deliberate attempt to deceive and confuse and disrupt the faithful. That book, of course, has given rise to a whole cottage industry of rebuttals, books that attack the various premises and misinformation that pervades Dan Brown's colorful but blasphemous novel. And Dan Brown, The Da Vinci Code, heralded by the press as a compelling blend of history and page-turning suspense, a masterpiece that should be mandatory reading, says the Library Journal. An exhaustively researched page-turner by Publishers Weekly. Astonishing, because it's full of misinformation and twists of history. And, to make matters even worse, is the subject of a major blockbuster movie by Ron Howard by the same name. So it is very much launching a tsunami of sorts across our culture, raising questions, certainly feeding the skeptical and confusing the marginally faithful, and should be challenging those of us that take the Bible seriously to really understand its origins and its foundation. While all this is going on, the National Geographic wants to get into the exploitation here. In their May issue of 2006, they have a feature article on the Judas Gospel, and obviously exploiting, as the best they can, the groundswell from the Da Vinci movie, which is being released that same month. The National Geographic has a very slick presentation, very skillfully designed to undermine traditional biblical beliefs. And the Gospel of Judas, which is the subject, was discovered back in the 70s. It was known and refuted by Irenaeus back in 180 AD. It's not new news, and it's certainly not historical, but it's among those documents that are used by people who don't really know their Bible to confuse. Mel Gibson did a movie called The Passion. His reviews were a little different than Dan Brown's. The New Republic said a repulsive, masochistic fantasy, a sacred snuff film, they called it. Courting bigotry in the name of sanctity, according to the New York Times. A real nutcase whose ulterior motive was making money, according to 60 Minutes. You know something strange going on here? Why is the Passion excoriated and the Da Vinci Code extolled? Why are Gibson's motives denounced and Brown's dignified? You see something upside down here? Why is Christ's passion regarded as a repulsive masochistic fantasy, and the supposed marriage between Mary Magdalene touted as researched material fact? Nothing could be further from the truth. So these are attacks, of course, from the pagan left, very organized, very sinister, and possibly very much motivated supernaturally. Dan Brown's Da Vinci Code, of course, is one of these things. The National Geographic, following right on its tail, is another we're witnessing. The Jesus Seminar, an astonishing array of pseudo-experts who exchange subjective, speculative hunches, replacing serious scholarship. Peter Jennings' TV special. You never find out the real motives behind that. The History Channel, the banned books of the Bible. Hugh Schoenfield, many years ago, back in '66, the Passover plot, that this was all some kind of scheme. And The Last Temptation of Christ in 1960, and on it goes. Even Mel Gibson's phenomenal movie fails to communicate just who Jesus Christ really is. And that is the crux of the whole issue in the first place. So what's going on here? Political correctness in an increasingly secular culture, or even something more sinister? A reversal of values. Fiction is promoted as fact, and fact, even the deity of Jesus Christ, is passed off capriciously as mere fiction. Even the undeniable grandeur of the creation itself is attributed to the randomness of a cosmic accident in our schools and in our culture. How astonishing. How distant this is from any real grasp of reality. Well, the traditional defenses of scholarship, of course, by pastors and others, would get into the manuscript evidence, talk about the incredible implications of the Dead Sea Scrolls. We could talk about advanced documentary technologies, the scanning laser microscope and such things that have brought earlier dating to the most important manuscripts, dated contemporaneously with the events they record, and the fact that we have contemporary eyewitnesses in which none of them, not one of them, recanted, even though they suffered torturous deaths. Very, very compelling evidences, but we're not going to focus on that traditional approach. We're going to go a little different way. By the way, advanced technology was to the rescue. A scanning laser microscope can differentiate between 20 micrometers of the papyrus, measuring the height and depth of ink, as well as the angle of the stylus used by the scribe. They can even tell whether he's right or left-handed and so forth. They've learned a lot in recent years, and Karsten Thede, using the Magdalen Greek papyrus from Oxford College, was able to date it essentially contemporaneous with Matthew, and it corresponds with Textus Receptus for those that are interested in that sort of thing. But we're not going to go down that path. The key fact here, of course, is that it was dated much earlier than some of the skeptics have said in the past. But we're also going to hear a great deal about the Gnostic Gospels. Not even the most radical scholar seriously believes that the Gospel of Thomas, for example, was written by Thomas of the New Testament, or that the Gospel of Philip was written by the Philip of the New Testament, and so forth. These are apocrypha, all under false pseudonyms. They were attributed to the apostles to give their speculations legitimacy. They're not Gospels, by the way. They don't have any historically verifiable facts. They're just opinions, speculative opinions. The early church rejected any documents that were written under pseudonyms because they felt it was inconsistent with the concept of divine inspiration of the New Testament. And all these Gospels, Gnostic Gospels, were written centuries after the Gospel period, typically in the 3rd and 4th century. And they contrast with the eyewitness accounts that we find in the New Testament. And they make no real pretense of being an actual record of events. They're really just speculations of various kinds. And they're anti-historical rather than simply non-historical. But these so-called Gnostic Gospels, the Gnostics, of course, believed that salvation came through hidden knowledge that they had. And there's a whole collection of these that were found in Nag Hammadi, a village in Egypt. The Gospel of Thomas, the Gospel of Philip, the Gospel of Mary, the Gospel of Truth, and about 4 dozen others of these. Sort of reminds you of Matthew 13, where we find Jesus describing these birds that pick up the seed of those that were not grounded properly. When anyone heareth the word of the kingdom and understandeth it not, then cometh the wicked one, as typified by the birds in the parable, and catcheth away that which was sown in his heart. The parables of Matthew 13 highlight the very thing we're witnessing here. Paul warns Timothy, his protege. He says, "For the time will come when they will not endure sound doctrine, but after their own lust shall heap to themselves teachers having itching ears. And they shall turn away their ears from the truth and be turned unto fables." And that's exactly what we're watching happen in our culture. So why are these things accepted? Certainly not due to any serious historical research. There's not one single verifiable fact in any of these. A fable, simply, that some have chosen to embrace. Napoleon was famous for saying, "What is history but a fable agreed upon?" And a pretty cynical outlook. The spirit of our times. Doctrinal diversity is the order of the day. Pressure of feminism. The quest for a do-it-yourself religion. A religion that's popular rather than necessarily true. So what we're going to do as we approach this topic, I'm going to call, for lack of a better term, Epistemology 101. We're going to get right at the basics of this. Epistemology is simply the study of knowledge in terms of its scope and its limits. And how do we know anything? How do we learn anything? Let's talk about that for a bit. When we were very, very small and in a playpen, our world consisted of that playpen. That was our boundaries that we could deal with. In that environment, we got a little familiarity with acoustics, visual colors, touch and textures, three-dimensional perception began to take place, basic motor skills to be able to reach and pick up and so forth. Then as we matured, our world broadened to our playroom. Our universe expanded within the confines of our playroom. So we began to have more discernment of things. We began to get introduced to rules and an order to our routine. We faced increased challenges of things that we could deal with, but also increased hazards. Hopefully, with adequate supervision, nothing serious occurred. So as we matured, our next boundary was expanded to our homes. And there we had increased mobility and challenges. We had, again, hazards and even potential disasters if we failed to be responsive. And more and more, subjection to guidance was essential as we had the mobility of our home. Pretty soon, as we go further, we got to school, and our universe began to expand. We had even more increased mobility and challenges, increased hazards. Subjection to guidance was even more essential until we finally were members of the community. And we had to learn how to handle unanticipated events. And we more frequently encountered things that were less predictable. And we had to start qualifying our sources of guidance, not just our parents, but others in whom we could place or shouldn't place confidence. And of course, as we matured as adults, our universe expanded to the world itself. And again, more and more, it was incumbent upon us to qualify sources of information about the world that we live in. And ultimately, of course, we're now facing the cosmos itself, the universe, in some much broader sense. And so, now as we went from the playpen, our epistemology was very heavily influenced by trial and error as we tried things and tried to learn from them. And we began to get some internal processing of what we were learning and, of course, getting some external guidance. As our boundaries expanded, our trial and error became less a percentage. More and more we had guidance. And as our boundaries continued to expand, the trial and error mode of our gathering information decreased, and our internal processing and external guidance becomes more and more paramount until we get further and further to where finally facing the cosmos where the trial and error factor is pretty de minimis. It's pretty hard to conduct experiments on the universe itself. And yet more and more are we dependent upon qualifying sources of information for guidance. And so that's a perspective from which there are some issues that we're facing. Cosmic issues. Is the universe infinite or finite? The great discovery of 20th century science was the discovery and the realization that the universe is not infinite, it's finite. How long has it been there? All kinds of guesses. A very elusive science at best. More to the point, was it designed or simply the result of some kind of cosmic accident? It's really quite astonishing to see learned people come to very, very bizarre conclusions. Are there limits to size? How large is the universe? How small are the smallest elements? That may be surprising, what we've discovered about that. We speak of empty space. Is space really empty? Has time always been the same? Are there other dimensions beyond the four that we experience directly, the three spatial dimensions and time? Those are issues. So we're going to explore the boundaries of our reality, and that's going to be our primary epistemological challenge in this session. And we're constantly subject to illusions of various kinds. And these illusions can be colorful minor things, or they can be very profound issues that we're facing. So first thing we're going to try to do is develop a critical perspective. There are two concepts very frequently discussed in mathematics that we cannot find in our physical universe, surprisingly enough. One is infinity. We talk about it, we put it in equations, we can deal with it conceptually. Can we find anything in our universe that's really infinite? And the other concept that's just as elusive is a concept called randomness. Randomness. There are mathematical tests for a series of numbers to see if they're random or not. It turns out that if you're faced with designing a computer and you need a source of random numbers, that turns out to be a major challenge because we discover there is no such thing as randomness. There are things that come close to randomness. In the computer field, you have what's called pseudo-random number generators because a true random number turns out to be surprisingly absent from our physical universe. That leads to a whole field of mathematics called the theory of chaos. We're also going to talk a little bit about the existence of hyperspaces. Fancy word for simply spaces that have more than three dimensions. We're going to talk about this to broaden our own personal horizons a bit here. So these two imputed concepts. The first is randomness. The professional term for this is entropy. You'll hear thermodynamics people others speak of entropy. Entropy is simply randomness in an absolute sense. And most engineers and scientists are trained in deterministic process. 2 + 2 = 4, always. 2 + 3 = 5, always, precisely. Those are deterministic concepts. In our real world, we encounter a field of processes that we call stochastic processes, where one or more of the variables involved are subject to randomness to some degree. And the whole field of advanced statistics deals with this. One of the frontiers of science called the design of experiments. How do you design experiments when you can't control all the variables? The major frontier, very powerful, critical tools involved there. The pseudo-random number area is an area that surprises many because you think that you could always find a random number. Try it sometime. you might resort to the famous publication by the Rand Corporation, 100 million random digits. And it turns out even that, while it passes a number of tests, is not truly random. And that leads, of course, to a whole field of science called chaos theory that we won't spend time on here. But there are measures of information that we need to be sensitive to. We realize that there are opposites. If we speak of disorder and order, those in some respects are opposite from one another. We can tell when something is ordered. We can tell when something is disordered. You can take a deck of cards and you can see if they're in bridge order, for example, or if they're shuffled and totally, apparently random. So disorder and order are opposites. Noise and signals are opposites. An engineer will speak of the signal-to-noise ratio of a receiver. The signal is the part you're interested in. It's the part that carries information. The noise is what interferes with that has no information in it. Music, the opposite of that would be cacophony. And I'm sure many in our audience would suspect that in today's music it's hard to tell, but I won't go down that path here. Chaos, absolute chaos in contrast to cosmos. The term in the Greek of cosmos means ordered, to bring order out of chaos. So on the left, on the chart here, we have randomness. On the one hand, we have design, deliberate design or intent, teleology, if you will, on the other. We call that which is on the left, disorder, noise, cacophony, chaos, or randomness. The technical term for that collection of concepts is entropy. The entropy is maximized on the left side. On the right side, we call that information. It's the opposite of entropy. Order, signal, music, design. It's information. It's interesting that these two, entropy and information, are direct opposites of each other in the information sciences. And we also discover there seems to be a law pervading every field of science in which information tends to get degraded. Through time, entropy takes over. In fact, that becomes one of the primary laws in thermodynamics, is that we always move towards increasing entropy. The whole universe operates as if it's been wound up and is in the process of winding down, where we have order going to disorder. We see that in our garages. We spend a Saturday cleaning up the garage. How long does it stay that way? We clean up our locker in school, or we organize our desk. We spend a half a day straightening it all out. And how long does it take before it's helter-skelter again? See, there's a trend, without the intrusion of some design, things will drift to disorder, randomness. We observe that in every field of our endeavors. And it's interesting, the Bible makes reference to this. The lot is cast in the lap, but the whole disposing thereof is of the Lord. The way Einstein summarized this, Einstein said, God does not play dice. Do you know why? Because if he did, he'd win. He's in control even of the randomness. There is no such thing as a truly random event. So there's another concept that eludes us in our physical universe called infinity. We glibly talk about it in school, but where do we find it? Let's first explore infinity in the macrocosm, in the universe, in the large sense. And the great discovery of 20th century science, as I mentioned, is that the universe is finite, not infinite. And we have very finite boundaries. The initiation of the universe is known among some as the Big Bang, a singularity, and it ultimately will burn out and result in the ultimate heat death. All work is done by a temperature difference, and as work is done, that temperature difference decreases, and when the universe is of a total uniform temperature, no more work can be done, and the mathematical term would be ultimate heat death for the universe. See, in thermodynamics, we have three laws. The conservation of matter and energy is well known to most students, which says that you cannot create matter or energy. You can transfer matter into energy, energy into matter, but you can't create either one from scratch. In other words, first law says there's no way to win. The second law is the entropy law, the bondage of decay, that all thermodynamic processes are inefficient, less than 100%. There's some percent of the work that gets lost to the ambient temperature. And that's a very basic law of thermodynamics. The second law of thermodynamics, some people might rephrase that and say you can't even break even. There's no way to win, you can't even break even. The third law, many people are not familiar with, everything has a positive finite entropy. So the first law says there's no way to win. The second law says there's no way to break even. And the third law says you can't even get out of the game. But we'll focus very intensely on the second law before we get through here. Let's talk a little bit about thermal decay. Heat always flows from hot bodies to cold bodies. We experience that in many, many ways personally. If the universe was infinitely old, the temperature throughout the universe would be uniform, because heat would be always flowing to cold, and if it's infinitely large, you'd have a uniform temperature. And it isn't uniform, therefore it isn't infinitely old. This very simple observation tells you that the universe has an age. It's not infinite. And the universe had a beginning. And it's destined also for an ending for the very same reason. And that's what the Bible tells us, is that by him were all things created, that are in heaven, that are on earth, visible and invisible, whether they be thrones, dominions, principalities, or powers. All things were created by him and for him. And he is before all things, and by him all things consist. That word consist actually means sustains, holds together. The astonishing thing isn't just that the creation has been created, is that it is maintained. There's some very delicate balances that we'll talk about shortly. The book of Hebrews says much the same thing. God, who at sundry times and divers manners spake in time past unto the fathers by the prophets, hath in these days spoken unto us by his Son, whom he hath appointed heir of all things, by whom also he made the worlds, who being the brightness of his glory and the express image of his person, upholding all things by the word of his power, when he had by himself purged our sins, sat down on the right hand of majesty on high. Wow. Upholding all things by the word of his power. The need for maintaining the creation is something we're going to encounter as we get into this further. Now, this idea of the beginning, it having a beginning, has led to a series of speculations that go by the name the Big Bang. Basically, the Big Bang says first there was nothing, and then it exploded. If that makes sense to you, you're welcome to it. But the first model, called the steady state model, Einstein admitted was his biggest mistake of his career. It was replaced in the 60s or by the hesitation model, which was refuted in the 60s for a number of reasons. Then it was replaced by an oscillation model. It expanded and contracted, this kind of thing. And that's refuted by the entropy laws and also the lack of mass. The current thinking is pretty much along the lines of what's called the inflation model. The problem with it, it requires anti-gravity forces that have never been observed. So these are just speculations. They're attempts by people to speculate on how it all began. There's another factor, and I'm going to call it the stretch factor. The expanding universe appears to be involved in expansion of about 10 to the 12th. And that comes from the temperature of the quark confinement when matter freezes out energy. And we don't have to go down the physics path there to justify this estimate. But it's interesting that with an expansion of 10 to the 12th, scientists estimate that the universe is about 16 billion years old. Well, that turns out to be about 6 times 10 to the 12th days. And so with that expansion factor, you come to the same term that God himself used with his own finger when he wrote it in stone in the book of Exodus chapter 20, that 6 days it was created. If you take the exponential factor, it would imply that these days, from God's point of view, are 15 billion years old. What kind of clock was running at the time? We don't know, because Adam hadn't been created yet. So it depends whose clock you're talking about. And there's a whole issue there of just how old the earth is. It turns out, can it be 6 days or 16 billion? Both are probably true, each in their respective frames of reference. But stretching the heavens, let's talk about the fabric of space. Is this more than a metaphor? In the scripture it speaks of God who alone stretches out the heavens. In Psalms, he's stretching out the heaven like a tent curtain. In Isaiah, who stretches out the heavens like a curtain and spreads them out like a tent to dwell in. He has stretched out the heavens. The Lord who stretches out the heavens in Zechariah and so forth. We have literally dozens of references where this same term is used throughout the Bible. Is it just a figure of speech? Today we discover that space is not, as most of us suppose, an empty vacuum. It can be torn, according to Isaiah 64. It can be worn out like a garment, according to Psalm 102. It can be shaken, in a number of references. It can be burnt. It will be burnt up, according to 2 Peter 3. It can split apart like a scroll in Revelation 6. It can be rolled up like a mantle or a scroll. In both Hebrews and Isaiah use that frame of reference. Well, that's an interesting clue here, what we're talking about. The properties of space. We know today that empty space has an energy level that's astonishing. 100 million suns equivalent. 10 to the 95th ergs per cubic centimeter. We'll talk about that in a minute. It has permittivity, magnetic, or actually a dielectric constant. It has permeability, a magnetic constant. Any amateur radio operator knows he's got to tune his antenna to the electrical properties of space itself. The intrinsic impedance, which derives from both of those, and then the velocity of light, which is presently estimated to be more than 2 times 10 to the 10th its present velocity at creation. It's currently at the speed of gravity. And the fact that the velocity of light has been changing is the astonishing discovery of just the last few years. And so that there's a major upheaval going on in the field of physics as we realize that these things we thought were constants are not constants. And we'll talk about that in a minute. 0-point energy. If the temperature of an empty container is lowered to absolute zero, there still retains a residual amount of thermal energy that cannot by any means be removed. So that's why they call it the 0-point energy. What we think of as a vacuum, we now know is a vast reservoir of seething energy out of which particles are being formed and annihilated constantly. Why doesn't an electron, as it spins around its nucleus, get attracted by the nucleus and simply radiate energy and spiral into the nucleus? You get the picture there? You'd think it would just disappear. It picks up energy from the background 0-point energy and therefore is sustained by it. So there is a sustaining going on right at the atomic level. How about being rolled up? There's some dimension in which space must be thin if it can be rolled up, and it also must have some direction that it can be bent toward. So these terms in the Scripture give us a clue that there are dimensions to space beyond the ones we experience. You and I think of a 3-dimensional space, length, width, and height. 3 dimensions are what we think of embraces space. We now know today there's more to it than that. There are additional spatial dimensions, and the Bible has said that all along. So let's talk a little bit about hyperdimensions, which is simply a term for spaces of more than 3 dimensions. And we're going to go beyond Euclid. Most of us have taught in school what we call Euclidean geometry. But it turns out that the most important speech in mathematics was given on June 10th of 1854 when George Riemann introduced us to metric tensors, the mathematics. It took 60 years before that mathematics would yield the theory of relativity by Dr. Einstein, which he discovered in 1915, the 4-dimensional space-time. We're going to talk a little bit about that in more detail in the next session, but we know today that you and I don't live in 3 dimensions, we live in at least 4. Length, width, height, 3 spatial dimensions, and time is a 4th dimension. A physicist will never speak of space or time separately. If he's careful, he'll always speak of space-time. Space and time can't be separated. The Planck's constant is a 4-dimensional constant. And Klose-Klein in 53, Einstein went to his death frustrated because he couldn't resolve other issues. If he'd done the same thing he did to resolve the first one, simply go up a level, it would have yielded. And in 53, a couple by the name of Klose and Klein went beyond the 4 dimensions and resolved the light and supergravity issues. And then in 1963, Yang and Mills went further to establish the electromagnetic and nuclear forces, combining all of them into a multidimensional perspective. And in 1984 and following, the current speculations have to do with superstrings. Most particle physicists will tell you they believe we live in at least 10 dimensions, not just the 3 that we directly experience or the 4, including time, much more than that. The dimensions of reality. It's interesting to notice that an ancient Hebrew scholar by the name of Nachmanides, who wrote in the 13th century, in his commentary on the book of Genesis, he concludes that the universe has 10 dimensions. Only 4 are knowable in his vocabulary. 6 are not knowable. Well, particle physicists today, in the 20th century, have discovered, or they now believe, that there are 10 dimensions. 4 are directly measurable. 3 spatial dimensions in time. 6 are curled in less than 10 to the minus 33 centimeters, and thus are inferable only by indirect means, because they're smaller than light itself. This fascinates me that we've spent millions of dollars building atomic accelerators to discover what Nachmanides discovered by just reading carefully Genesis chapter 1. Hyperspaces. There are only 2 kinds of people that are able to deal with hyperspaces. Mathematicians with special training and small children. They have no trouble with this at all. But you and I can get some insights into dimensionality. We can't go up without special training, so to speak. But we can look down. In our imagination, we can look down from our 3-dimensional world down to a 2-dimensional world and draw some insights from this. So I want to introduce you to Mr. and Mrs. Flatt. I want you to be compassionate because Mr. and Mrs. Flat suffer from a very serious handicap. They live in only 2 dimensions, and they live in a 2-dimensional universe. And so if we can imagine a universe of only 2 dimensions, and we're dealing here with what in school we'd call plane geometry, plane, it's flat, 2-dimensional universe. Mr. and Mrs. Flat are there. If you and I come along as a 3-dimensional being, we can be more intimate with either one of them than they can with each other. They could be yards apart, and we could, because of our additional dimensionality, be a millionth of an inch from each of them. So we enjoy a proximity that's totally independent of the distance between them because we have an additional dimension. This is just one example. We could go on with other examples. If we managed to penetrate the 2-dimensional world, they would behold us as simply a circle because they have no conception of the space beyond the 2 dimensions that they have availability. If a sphere should fall through their 2-dimensional universe, it would show up as a dot, expand to a circle, shrink back to a dot, and disappear. There are serious scientists that believe that UFOs are hyperdimensional events. There are many that believe that angels are hyperdimensional creatures. And those are speculations, but they can be justified from the insights we have from modern science so far, at least. Well, how would you communicate a 3-dimensional object to a 2-dimensional universe? Suppose we had a reason we wanted to communicate to Mr. and Mrs. Flat our 3-dimensionality. How would we do it? Well, one way to try to do is let's make a 2-dimensional projection. We do that in drawings. We have what we call a projection. That's not too useful. If I take a 3-dimensional projection of a 4-dimensional hypercube, it's really not very useful. There's some of these on the internet you can play with, but as you play with them, all they really convince you of is you can't instinctively really understand what's going on. Not very useful. Another way we might try to communicate a 3-dimensional object into 2 dimensions is to unravel it into 2 dimensions. We might take a cube and unfold it like a box into a 2-dimensional representation of the box. Well, we suspect that if we did this, Mr. and Mrs. Flat would still have a hard time perceiving what we really meant by a 3-dimensional cube. There is a 4-dimensional cube that's been unraveled in 3 dimensions. It's called a tesseract. And the only place I've ever seen one, other than a mathematics textbook, is in a piece of art, a very interesting piece of art by Salvador Dali, Corpus Christi, where he renders the cross as a 4-dimensional cube unraveled in 3 dimensions. It astonished me to realize that Salvador Dali had that sophistication in topology and mathematics to be able to even understand what he was saying there. Very effective use of it, as a matter of fact. But I want to show you another passage in the letter to Ephesians. In Ephesians chapter 3, Paul writes that Christ may dwell in your hearts by faith, that ye, being rooted and grounded in love, may be able to comprehend with all saints what is the breadth and length and depth and height, and to know the love of Christ which passes knowledge, that ye might be filled with the fullness of God. As you read that letter, you may miss something unless you look carefully. Have you noticed this? How many dimensions is Paul writing about? The breadth, the length, the depth, and height. 4 dimensions, one of which is a Greek term that can embrace time. Kind of interesting. 4 dimensions. The Bible's really said that all along. So we've been through randomness. We're now infinity. We've talked about the macrocosm, our universe that is finite in the macro sense. Let's take a look at the microcosm, at the smallness. We know the universe has a limit to how big it is. It may astonish you to realize there is a limit to smallness. And we call that quantum physics for some very interesting reasons. If I told you that this podium I'm speaking of is empty and not solid at all, and you took the view that, no, it's obviously solid, do you realize that I am 10 to the 15th more accurate than you are? If we take an atom, a simple atom being a nucleus surrounded by an electron, turns out, this is obviously not drawn to scale, because the atom is 10 to the minus 8 centimeters in diameter. The nucleus 10 to the minus 13th. Okay? That's a difference between the two is 10 to the minus 5. Or 10 to the 5th, you're going to divide it. So if you take that volumetrically, 10 to the 5th, and cube it, you got 10 to the 15th. How big is 10 to the 15th? Well, that's not very distant from the number of seconds in the universe. If you take 16 billion years old and divide it into seconds, you have about 10 to the 16th, 10 to the 17th. Almost, this number almost reaches that kind. It's a very, very large number, which means simply this, that most of this podium is actually empty space. It feels solid because of an electrical simulation being occurred between atoms that sense each other's nearness. But it's mostly empty by a factor of 1 part in 10 to the 15th. So if I say there's nothing here, I'm 10 to the 15th more close to reality than you are if you say this is solid, because it's obviously not solid. There's no such thing as solid, it turns out. If we take a line and cut it in half, we can take what's left and cut it in half again. We can take what's left and cut it in half again and keep doing that. You would think that we could keep doing that, at least conceptually, forever. That no matter what we have left, we can cut it in half. It turns out that that's not true. It turns out that when we get to 10 to the minus 35 centimeters, if we try to cut that in half, whatever's there loses locality. It's suddenly everywhere at one instant. And an astonishing number of experiments back in 1982 confirmed this whole idea of what they call the Bell inequality. The net of it is that all photons in the universe know what all the other photons are doing. They're all interconnected in some strange way. And that's what leads, by David Bohm and others, to what they call the holographic model of the universe. But the very fact that subatomic particles have a property that's known as non-locality is astonishing. And this is true not just of length, it's true of mass, energy, and time. The Planck length here is 10 to the minus 33. The Planck time is 10 to the minus 43 seconds. There's no time smaller than 10 to the minus 43 seconds. The entire universe is made up of digits. It's a digital simulation. And so we have infinity at the macrocosm, it's finite. At the microcosm, it's finite. That's what leads to the field of, they call these indivisible units quanta, and the study of them is called quantum physics. And so we discover that you and I are in a physical universe that has boundaries. There's a finiteness of this, a very large, but still a finite size on the macro side, and it's also made up of indivisible units on the small side. It has a grain. It's digital, not analog, in effect. There's a movie that came out some time ago called The 13th Floor, which has nothing to do really with the major plot of the movie, but I think it's instructive to take a perspective of it. The movie in Los Angeles in 2005, a group of computer experts built a virtual simulation of a city and people, and they chose to create Los Angeles 1937 in this imaginary virtual environment, and all software. It was a virtual environment and populated with virtual people. And what made the thing kind of interesting is that they call the people in the software system a program unit, and people from the real world could enter that world for a brief period of time, for an hour or so, by exchanging their consciousness with the consciousness of the virtual people. This is obviously just a science fiction story, but very cleverly crafted. And so these people were able to go for a while in LA 1937 and live for an hour or so in the bodies of the people, certain people there. And in the plot line of the story here, a murder mystery takes place. There is a major program manager that has been murdered, and it turns out the key to solving that murder is in the virtual environment. And that causes our hero in the story to have to go into there to try to solve, because they're going to pin this murder on him if he can't solve it, and that's what the plot line has to do with. And where the plot takes a huge twist is they discover there are other people entering LA 2005, and it turns out when the smoke finally clears, they're coming from LA 2025. And they discover then, as they realize all this, that even they themselves and the world they're in is a virtual environment. And it's a very cleverly crafted science fiction story. But what makes the thing so provocative, just a piece of entertainment, don't misunderstand me, just a piece of entertainment, but it's conceptually provocative here, because that's exactly the predicament we find ourselves in. That we are in an environment, while we may make virtual games and things and so forth, that in fact we ourselves are in a simulated environment that in which there's a reality beyond ours. And Scientific American in June of 2005 wrote an article about constants. We're going to get that here in a minute. But they concluded, tentatively, that our reality that we live in is but a shadow of a larger reality. That's their words, not mine. And so we find ourselves very analogous to that situation. We're here, man is here, and let's do a spread of size. On the large scale size, we have astronomy and astrophysics, the universe, but we discover it's finite. The macrocosm is finite. On the small side, we have indivisible units. That leads to quantum physics. Subatomic particles cease to have locality if they're divided. And that's at the microcosm. So we find ourselves, fascinatingly, inside a digital simulation. Everything we have is made up of indivisible units. It's like a piano rather than a violin. A violin is analog. A piano is digital. You have to hit one of the keys that are there. And that's exactly what they're discovering with the red shift. The red shift is digitized. That shakes everybody up. So there are finite limits to the simulated world we find ourselves in. And we can go one step further and call this total thing the metacosm and talk about it, but we'll have to get some. And it's Scientific American 2005 says, our universe is but a shadow of a larger reality, is their conclusion from the fact that the constants of the universe we're now discovering are not really constant at all. And Paul Davies, a secular scientist, says, it seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming. When they try to build a mathematical model, a three-dimensional model of the universe, they discover there are relationships that cannot be violated or it all falls apart. It's very, very tightly tuned. And they call it's as if it was all designed for mankind. So this concept that they encounter is called by them the anthropic principle. It's as if the universe was designed for man. Let's take a look at it. It's the appearance that the universe was designed. In constructing the model, we believe that we know about, of everything we know about the universe, there are hundreds of delicate ratios, if altered in the slightest, would render life impossible. And sometimes 1 part in 10 to the 55th, surprisingly enough. As we understand the universe, there are 4 basic forces that are encountered. Gravity we all know about, electromagnetic force we know about, and there's 2 nuclear forces, strong and weak nuclear forces. These 4 forces explain everything that we know about in the universe. Gravity that's what causes an apple to fall to the ground, keeps our feet on the floor, binds together our solar system, keeps the Earth and the planets in their orbits in effect, prevents the stars from exploding, and guides the galaxies in their motion. That's what gravity is all about. There's another force that operates closer in called electromagnetic force. It holds the atom together. It determines the structure of the orbits of the electrons and therefore all chemistry. Governs the laws of chemistry. The forms of electromagnetic force can include X-rays, radio waves, and of course light. And it can overcome gravity on the Earth. So for short distances, it can overcome gravity. And it can dominate other forces down to the size of the nucleus of an atom. There things start to change. That's where we encounter 2 nuclear forces. The strong nuclear force is what binds the protons and neutrons in the nucleus of the atom. The balance between the strong force and the electromagnetic forces limit a nucleus to about 100 protons, and that's what limits basically what we know as the periodic table. The energy release is substantially greater than electromagnetic, that is the chemical forces, and thus that's what causes stars to shine, essential for life and so forth. The weak nuclear force governs atomic instability and radioactivity, the disintegration of heavier nuclei. It can create heat, such as the decay of radioactive elements in the Earth's core, or in a nuclear power plant. So these are 4. Now, the gravitational coupling, if let's just take each one of these. If the gravitational coupling was a little bit stronger, all stars more massive than our sun by about 1.4 times, they burn too rapidly, they do inconstantly to maintain life-supporting conditions on surrounding planets. If it was just a little bit weaker, all stars would have less than 0.8 times the mass of our sun. There would be no heavy elements in the universe. Electromagnetic coupling. If it was a little weaker, the molecules of life would cease to exist. If it was slightly stronger, the molecules for life would cease to exist. It happens to be just at the right amount. The strong nuclear force coupling. If it was slightly weaker, multi-proton nuclei would not hold together. Hydrogen would be the only element in the universe. If it was slightly stronger, nuclear particles tend to bond together more frequently and more firmly. Hydrogen would be very rare in the universe, and the supply of various life-essential elements would be heavier than iron, would be insufficient. The weak force coupling. If it was larger, there'd be no helium, no heavy elements. If it was weaker, everything would be helium, and there'd be an overabundance of heavy elements. the ratio of electron to proton mass. If it was larger, the molecules would not form, life would be impossible. If it was smaller, molecules would not form, and life would be impossible. It happens to be just at the amount it has to be. The distance from the sun. If we were closer, it'd be too warm for a stable water cycle. If it was further, it'd be too cold to have one. Surface gravity. If it was stronger, the atmosphere would have too much ammonia and methane. If it was weaker, atmosphere would lose too much water. The thickness of the Earth's crust. If it was too much oxygen if it was thicker, too much oxygen would be transferred from the atmosphere to the crust. If it was thinner, volcanic and tectonic activity would be too great. It's right in an ideal balance. The Earth's rotation period. If it was just a little bit longer, the diurnal temperature differences would be too great. If the days were too short, it would get too hot and too cold, if you will. If it was slightly shorter, the atmospheric wind velocities would be too great. These are all discoveries that are astonishing people to realize how delicate everything seems to be balanced. The axial tilt. If it was greater, the surface temperatures would be too great. And if it was less, the surface temperature would be too great, for different reasons, obviously. And the albedo, that's the reflectivity of the planet. If it was a little greater, a runaway ice age would develop. If it was a little less, a runaway greenhouse effect would develop. It's just at that right balance. The Earth's magnetic field, if it was stronger, the electromagnetic storms would be too severe. If it was weaker, there'd be inadequate protection from the hard stellar radiation. The ozone level, I love this one. If it was greater by just a little bit, surface temperatures would be too low. If it was less, surface temperature would be too high and too much ultraviolet radiation at the surface. But the reason I think this is kind of interesting is the ecologists tell us that, if the ozone level was just a fraction of a percent, a tenth of a percent more or less, it brings cosmic doom. When they say that, turn that coin over. If it's that delicate, who balanced it in the first place? The fact that it's that delicate is an argument that it didn't occur randomly. By the degree it's rare to the degree it excludes randomness as a source. Furthermore, it raises another issue. Not only who balanced it, who is maintaining the balance? If it's that delicate, it would be intrinsically unstable unless there were countervailing factors involved. CO2 and water vapor. If it was greater, runaway greenhouse effect would develop, and if it was less, the greenhouse effect would be insufficient. So, at the atomic and subatomic level, the slightest variation in any of the primary constants of physics, some is less than 1 part in a million, causes life to be impossible. And that's just a reality. The more rare these relationships are, the more they unequivocally reveal both skillful design in their origin and diligence in their maintenance. That's something that's often overlooked. They have to be maintained. The ancient cultures created false gods of wood, stone, whatever, to worship. Our cultures invented the most insulting god of all that we choose to worship. Randomness, the total absence of information. We've chosen to worship the absence of information. Ignorance, strangely enough. Of all the false gods that man has worshipped, this one, the one we embrace in our culture, is the most insulting of all. In 1954, Sir Fred Hoyle, a scientist, predicted using the anthropic principle and then discovered the previously unknown energy of levels in the carbon-12 atom from its sensitivity to the prevalent patterns of numerical design in the universe. Very interesting event because he used the anthropic principle predictively. They were struggling with a carbon-12 issue, and he predicted a level of energy that they then tooled up and discovered was there. But he predicted it in advance of its discovery by applying the anthropic principle, a very, very interesting event from the point of view of science. You're going to hear more and more a term called the privileged planet, because not only is this planet that we live in uniquely positioned for life. As they study the universe and its billions and billions of galaxies and the number of planets that might be around those stars, they discover the offset is the rarity of the conditions for life are so rare that it still doesn't. It comes to the conclusion that we are unique in the universe, strangely enough. But we are also not only uniquely positioned for life, they've discovered something else. We're uniquely positioned to discover. The fact that you can have this first occurred to some scientists. They were watching the eclipse of the sun. The moon is exactly the right size and the right distance to create a total eclipse. it was a little bit bigger, a little bit smaller, you would not be able to see the corona. And by being able to see the corona, they were able to analyze it and discover not only what the sun is made out of, but by discovering that spectroanalysis, they can tell what other stars are made out of. But they also discovered it was as if it was tuned, not just for life, it's tuned to allow us to discover. As they begin to analyze our position in our galaxy, we're not too close or too far from the center to be able to see the rest of the universe. And just as we have an array of tuning that's gone on here to make life possible, we also are discovering there's an array of issues, dozens of them, that have been tuned to allow us the opportunity to discover. The fact that our eyes are sensitive to the visible, a very, very small part of the electromagnetic spectrum, but it's that very part of the spectrum that allows us to discover the universe itself. It says not only are we placed here as a beneficiary of life, we're also placed here as a beneficiary of the opportunity to discover. And we're positioned in the galaxy, positioned for total eclipses, positioned with the visible spectrum, and it goes on and on, dozens of these things. This implies more than accident. This implies teleology, a purpose. Not only are we designed, it indicates there was a purpose in the design. And there's a recent book out, The Privileged Planet, by Gonzalez and Richards, that I encourage you to get. There's also an astonishing video out by them, which uses computer graphics to demonstrate all these things. It's absolutely breathtaking. I encourage you to check into it. But I'd like to talk a little further about the constants of the universe in another way. It turns out that many of these constants that have dimensions are very, very sensitive. But there's two constants in the universe that are dimensionless. One that you're probably very familiar with, and one that you're probably not familiar with unless you've been active in very advanced engineering or math, what have you. The first one is pi. We all learned that in school, that the relationship between a circumference and a diameter is 3.14159, a bunch of other numbers. We call that pi. It's the ratio of the diameter to the circumference. That turns out to be true no matter what units you're measuring with. It's metric or English or what you name it. That relationship is intrinsic to the relationship between the diameter and a circle. There's another one called a natural logarithm, log to the base e, and I'll talk about that in a minute. It's kind of interesting to discover there are two key verses in the Bible about creation. Obviously, Genesis 1:1, in the beginning God created the heaven and the earth. And John 1:1. In the beginning was the Word was with God, the Word was God, and so forth. All things were made by Him. Without Him was not anything made that was made. So these are the two key passages in the entire Bible on creation. Well, it's been called to my attention that if you take the first verse of the Bible in the Hebrew, and Hebrew letters and Greek letters have the distinctive that they have numerical values, each one of them. And if you take the Hebrew here, Bereshit, bara, Elohim, and so forth, you take the number of letters times the product of the letters, and you divide that by the number of words times the product of the words, you end up, interesting enough, with pi to 4 decimal places. 3.14116, 4 decimal places. You say, well, gee, that's kind of a strange coincidence, but it is what it is. It turns out John Napier, who was a mathematician in the 16th, 17th century, activist for the Reformation and the Protestant affairs in Scotland, turns out. He was the inventor of what we know today as logarithms. The natural and Napierian logarithms are logs to the base e, or sometimes called natural logarithms. He also established the use of a decimal point in fractions. But the number e shows up in advanced math. Unless you've been in calculus or advanced math, you probably never run into it. It is a very unique kind of number. It has a limiting value of about 2.7183, or 28 on. It forms the base of the natural logarithms. It appears as an exponential function. It's the only function having a rate of growth equal to its own size. In the language of calculus, it's the only function having a derivative equal to itself. And therefore, it's a fundamental function for certain equations of growth and other processes. So they show up in wave mechanics. It shows up in electrical theory, advanced math, distribution of prime numbers. It shows up in the strangest places. And if you've been in advanced math, you've come across E as frequently as a geometry student comes across pi, if you will. Well, if you take the first, the key verse of creation in the New Testament, in the beginning was the Word was with God, the Word was God, John 1:1. You take that in the Greek, and there again do the same thing we did before. The number of letters times the product of letters divided by the number of words times the product of the words. Guess what? It comes to E, to 4 decimal places. Now, I don't know what you're going to do with that piece of information. It doesn't prove anything, but it certainly gets our attention. You see, the rabbis have a very strange view about the Torah. They not only believe God created the universe, they believe the Torah contains the templates by which he did it. Rather interesting point of view. But there are recent articles in some of the journals because they're discovering that the things that they thought were constant aren't. The speed of light was regarded as a constant. I was taken to dinner by a number of my old friends that were upset because I was publishing in our news journal over a decade ago articles by Barry Setterfield arguing that the speed of light is not a constant, that it's been slowing down. And my well-meaning Christian physicist friends said, Chuck, you're going down the wrong path. Everybody knows that there's nothing more sacred than the constancy of the speed of light. Undergirds most of physics. I was deaf to that. Was polite, but deaf to that. And it turns out that within the last couple of years, there's a number of articles in reputable journals that are discovering, my goodness, the speed of light is not a constant. And none of them had the character or the integrity to make reference to Barry Setterfield, who've been saying that for several decades. But nevertheless, they're now waking up to the fact that the constants of the universe are not constant. And there's studies going on to try to concern themselves with that. In Scientific American in June 2005, I love this phrase, they believe that our reality, our three-dimensional reality, is but a shadow of a larger reality. That's something the Bible has been saying all along. And we read that earlier. So we're going to go to the next part 2 of this What is Truth excursion. In examining our boundaries, we're going to talk specifically about the time domain, because it's going to be very useful to do so. We'll talk about entropy as the arrow of dimensionality to the time domain. We'll talk about negentropy being essential for life. We'll talk about extraterrestrial sources of information that we can draw upon, and how we qualify sources of information, and how we test hypotheses. So join me for part 2.